Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, I'm going to look at the concept of inverse of a matrix using row reduction to echelon form. And we're going to use the term the argumented in this specific discussion to be referring to this specific, of course, set of matrices which are going to be undergoing a transformation. Now, in this particular case, we're going to see that there's a procedure which we are going to involve in order for us to come up with the inverse of this specific matrix which we are going to be required to evaluate. And this is going to be referred to as particularly the argumented form which I've basically given on the board. Therefore, our task in this specific case, we are going to particularly be performing a task that is going to require us to have this specific form of a matrix A given as such and transform it into a form which can be given in terms of identity and the inverse of A, which is going to be given as such. So this is going to be basically referred to as the argumented form, and it's going to be assisting us in trying to, of course, evaluate an inverse of a matrix from this specific combination. And this is going to be involving the row reduction, of course, elementary procedure, which are going to be assisting us in trying to find this specific inverse. And we're going to use this particular example, which I've given for A on the board to achieve that specific objective. Now, in a sense, I'm going to be showing the particular, of course, matrices of A and B. And this is going to be also accompanied by the B and C, particularly C, which I've just given at the lower section of the board. Now, in our previous discussion, we had basically tried to look at the concept of reducing a matrix to echelon form. And we said that a matrix basically is in echelon form if the number of zeros preceding the first non-zero entry of a row increases row by row until, of course, we have 0 rows left. And we had used the first example in this specific case for us to demonstrate basically how we can be able to identify a matrix in an echelon form. And we said that for us to identify the leading entries, we're going to have the non-zero leading entries of each of the row. For the first row, we're going to have 2. The second row, we're going to have this specific number for 7. And then we're going to have a 6, which is going to be forming a third row. So we're going to see a succession of an increase of this number of zeros for this particular case, row by row, until we're going to be left by, of course, this specific version of the 0 rows. And this is going to be a matrix which can be given in terms of a row reduced, or rather a reduced matrix reduced to echelon form. And in a sense, we had basically included this specific section for the concept of a row reduced echelon form. And this row reduced echelon form, we're going to see that for the specific case of C, this is kind of the a 3 by 3 matrix which we can identify as identity. And this specific matrix is going to be given a term of a row reduced echelon form kind of a matrix. And we are given some of the specific conditions which are going to be required for us to have a matrix that is reduced to echelon form. Now, one of the conditions which we said, of course, is that the leading entries in each non-zero row is going to be 0, which particularly is going to be the case for us here for having the 3 specific rows whereby the leading entries are going to be, of course, non-zero, which are going to be given in terms of 1. And then we had said that on top of that, we're going to have each leading one in which is going to be forming the only, of course, non-zero entry in its specific column. Now, for the 3 sets of columns which we have seen in this case, then therefore they're going to be the only non-zero leading, of course, entries which are going to be particularly consisting of that specific column. Now, in a sense, therefore, we can give this C as a row reduced echelon form. And this is going to be one of the ideas that is going to be assisting us in trying to, of course, follow this particular procedure. And the matrix for C, which I've basically looked at in our last part, is going to be forming what we refer to as an identity. Now, as I mentioned earlier, then therefore, we're going to see that for us to have a matrix that is going to be, of course, giving us an inverse of a matrix using this row reduction to echelon form, we're going to use this specific, of course, a statement for us to try and achieve that specific, of course, evaluation, whereby, as I said, we're going to have the matrix of A given in argumented form, which is going to be transformed to, of course, this specific fashion, whereby we're going to have the identity given in terms of that particular set together with the inverse of that matrix. So therefore, our main objective is to acquire these specific steps, and we're going to involve a series of course, elementary steps which are going to assist us in trying to solve this specific aspect of or elementary row reduction or elementary steps which we had mentioned basically, which are going to be assisting us in trying to solve those particular questions. And this is going to be row operations which are basically mentioned in our previous discussion. So we are going to be having this particular statement, whereby we're going to see that every matrix that we're going to consider in this particular case is going to be a row equivalent of one and only one reduction, of course, or reduced echelon matrix. And this can be given perhaps in this specific case as a note which we have basically mentioned in our previous video, whereby we said that every matrix is, or we can say that is row equivalent to one and only one reduced echelon matrix. And this is going to be giving us this specific case of argument for us to, of course, perform this specific operation. Now, in a sense, we are going to consider this particular matrix which I've given for A, which is going to assist us in trying to achieve the same, whereby we're going to transform that specific matrix using this argumented form. So in a sense, I'm going to have a summary of these specific transformations. Now that we have looked at a series of what I referred to as elementary row operations in our previous video, I'm going to do this and then I'm going to elaborate on the various steps which, of course, we have involved in trying to reduce this specific matrix to an echelon form, which is going to be giving us this specific, of course, analysis for this, which is basically that is going to assist us in trying to identify or achieve this specific result for an inverse from these particular procedures which I've just mentioned. So this is going to be in form of so from the above evaluations, we are going to see that we can perform a series of these specific, of course, elementary row operations in order for us to obtain the results which we had said. And this is going to be given from the general formula which we had given for this specific aspect of argumented form for a transformation of a matrix to an identity, and of course given using that inverse of a matrix given as such. So in a sense, we're going to see that our first case for the transformation of this specific matrix of A given in this specific top right corner of the, of course, board is going to be transformed to this particular series. Now I'm going to be explaining this specific elementary row operations which I've just done, whereby we're going to see that in the first case, I'm just going to retain the first rows for the form of a matrix which I've given in terms of a 401. So this is going to be retained, and I'm going to transform row 2 and row 3 given as such. So as we're going to be transforming this specific section of a matrix A, this is going to be performed, of course, the similar operation is going to be performed for this section of an identity. And therefore, we're going to have row 2 transformed by having 2 times row 2 minus row 1. So in a sense, we're going to have that twice this amount of, for this specific, of course, element is going to be, of course, attained by a multiplication with this scalar over 2. And then we're going to perform a subtraction for this row 1. So therefore, we're going to expect that twice this element for 2 is going to be 2 minus 4, which is equivalent to 0. So we will have seen that the first element for the second row is going to be transformed to this specific set for 0, and then we shall have 2 times 2, which is going to be 4, and then minus 0 is going to be giving us 4 given as such. So this is going to also be 2 times this element for row 2, which is going to be 0 minus 1 is going to be giving us a negative 1 given as such. So for the next operation, we're going to see that we're going to have this section of the identity transformed by having 2 times this row 2, which is going to be 0 minus 1 is going to be equivalent to this particular element of this specific, so it's going to be 2 times this particular element, which is going to be 0 minus 1. This is going to be equivalent to 1 given as such. And then we're going to have this specific element for the second one. So basically for the first, of course, element of this second row of identity, we're going to have 2 times 0 is 0 minus 1 is minus 1. And then we shall have 2 times this specific element of 1 is going to be 2, minus 0 is going to be given as 2, and 2 times 0 is 0 minus row 1, which is going to be 0, is given as a 0. So we're going also to have the transformation for the third row, which is going to be given in terms of row 3 is equivalent to 4 times row 1. Basically, this is going to be given in terms of 4 times row 1. So we shall have this one given in terms of 4 times row 1 is equivalent to 12 minus 3 times row 1. So 3 times row 1 is 12. So 12 times 12 is 12 minus 12 is equivalent to 0. So we shall have this second one given in terms of 4 times row 3, which is going to be 4 minus 0. So this is going to be giving us a 0. And then we're going to have 4 times row 3, which is going to be 4 times 1, which is going to be 4, minus 3 times row 1. So it's going to be 4 minus 3 times, so 4 minus 3 is equivalent to 1 given as such. So for the side of our identity, we're going to have this specific operation given for 0, which is going to be 4 times 0 is 0, minus 3 times row 1, which is going to be 0 minus 3 is going to be minus 3. And the 0 times 4 is going to be 0 minus, of course, row 1, which is 0 minus 0, giving us a 0. And the last, of course, element of this specific, of course, section is going to be giving us 4 times row 3, which is going to be 4 minus 3 times row 1, which is going to be 4 minus 0, giving us a 0. So this is going to be a sequence of steps which we are going to be performing for each of the results which we are going to obtain from the section of identity, and of course this part of the matrix of A. So as we go by, we're going to see that basically we're going to be achieving this specific transformation by transforming row 2 and 3 to obtain this particular result. And we shall perform a subsequent transformation for row 3 in this particular case for us to, of course, obtain this specific matrix from this one by having a row 3 as a row 3 minus row 2, which is going to be, of course, giving us this specific matrix. And this one, we are going to perform a specific operation for row 3, which is going to imply that we're going to maintain row 1 and 2. And therefore, row 3 is going to be, of course, transformed by a division over 2. So therefore, that's going to be seen for this specific number of values which are non-zero. This is going to be given as 3 minus, this is going to be 2 divided by 2, which is 1. And the rest is going to be giving us the individual results which we have shown above. So this is going to be followed by a transformation of row 2, which means we're going to maintain row 3 and 1 given as such. And this is going to be giving us a result of that one. And therefore, this is going to be followed by a subsequent transformation of row 2, which means we're going to retain row 1 and 2 for this particular result. And we're going to have this second last transformation of row 1, which is going to be, of course, giving us a division by 4. And therefore, this is going to be resulting to this specific, of course, matrix. And then lastly, we are going to perform this division of course, row 1 by 4, which is going to be assisting us try to achieve this specific result. And therefore, as we can see from this particular result, we are going to have this form of an answer for the matrix given in terms of identity. And of course, the one that we're going to achieve on this other side is going to be representing our inverse of the matrix. So therefore, we can have this inverse of the matrix given in terms of this specific representation, whereby we are going to have this one. So I'm going to, I hope that we have followed from this specific section, or rather we can just give it as a matrix in this. So let's just do of course a set of a matrix for the inverse of a matrix.